The approximate depth of an ocean is 2700 meter. The compressibility of water is 45.4 into 10 to the power minus 11 per Pascal, and density of water is 10 to the power 3 kg meter per meter cube. What fractional compression of water will be obtained at the bottom of the ocean? This depth is h and compressibility is k, and this is density of water rho. A ocean this is top surface and this is bottom of ocean. The height is h. Surface पर pressure is atmospheric pressure Pa. Bottom पर pressure will be Pa plus rho g h. Change in pressure will be delta P Pa plus rho g h minus Pa is equal to rho g h. Compressibility K 45.4 into 10 to the power minus 11. Bulk modulus will be reciprocal of K, and that is 45.4 into 10 to the power minus 11, 10 to the power 11 upon 45.4. B is equal to minus delta P by delta V upon V. So, fractional compression delta V by V is equal to minus delta P by B. Delta P is rho g h and B is 10 to the power 11 by 45.4 minus 45.4 rho g h by 10 to the power 11 and minus 45.4 10 to the power 3 9.8 into 2700 by 10 to the power 11. This comes minus 1.2 into 10 to the power 2 minus 2. Minus sign shows that volume is decreasing. 1.2 into 10 to the power minus 2, this C is correct option. Next, a wind with velocity 40 meter per second blows parallel to the roof of a house. The area of the roof is 2500 meter square. Assuming that the pressure inside the house is atmospheric pressure, the force exerted by the wind on the roof and direction of the force will be. Density of air is 1.2 kg per meter cube, 4.8 into 10 to the power 5 Newton downward, 4.8 into 10 to the power 5 Newton upwards, 2.4 into 10 to the power 5 Newton upward, 2.4 into 10 to the power 5 Newton downward. एक हाउस, this is roof. Thickness of roof is negligible. तो inside pressure is atmospheric pressure PA और यहाँ पर upward direction में wind is blowing with velocity v 40 meter per second. Suppose यहाँ पर pressure is P. Area of roof is 250 meter square. And rho of air is 1.2 kg meter per cubic meter. तो डाउनवर्ड सरफेस अगर सरफेस नंबर 1 एंड अपर सरफेस इज 2, अप्लाइंग बर्नौली's थ्योरम at surface 1 and 2, 1 पर टोटल हेड होगा PA अपॉन रो जी, रो इज रो एयर, प्लस Z1 potential head plus velocity head V1 square by 2g and अपर सरफेस पर होगा P by रो एयर इंटू G प्लस Z2 प्लस V स्क्वायर बाई 2g. Z1 और Z क्योंकि नेग्लिजिबल थिकनेस ऑफ द रूफ है, हैंस Z1 और Z2 क्रॉस ईच अदर. V1 इज वेलोसिटी डाउनवर्ड डाउन साइड में, दैट इज 0. तो दिस विल आल्सो बी 0. पी ए अपॉन रो एयर into Z will be equal to P upon rho air into Z plus V square by 2Z. PA is equal to P plus half rho air into V square, or PA minus P is half rho air into V square, and half into rho air is 1.2 into this velocity is 40 by square, 0.6 into 1600 96000 Newton per meter square. PA is greater than P, hence pressure, net pressure will be upward direction. Net pressure will be upward. Total force exerted by the wind, total force will be PA minus P into area of the roof. 960 into 250 Newton, and direction is upward. 0, 240. 2.4 into 10 to the power 5 Newton, and direction is upward. This C is correct option. Next, the cylindrical tube of a spray pump has radius R, one end of which has n fine holes, each of radius R. If speed of liquid in tube is V, the speed of ejection of liquid through the holes is. A cylindrical tube, यहाँ पर n होल्स, n, and this is radius is r, और एक होल का यहाँ पर स्मॉल होल का रेडियस इज स्मॉल r. Area of cross section of this tube A is pi r square. Area of cross section of these n holes, एक होल का एरिया है पाई स्मॉल r स्क्वायर, तो n का n पाई स्क्वायर. A1, दिस इज A1. यहाँ पर सपोज वेलोसिटी इज V1 और यहाँ पर वेलोसिटी इज दी गई है V. दिस continuity, as per continuity equation, Q is AV is equal to A1 V1 and V1 is equal to AV by A1. A is pi r square into V by n into pi r square. pi से pi क्रॉस हो गया, V r स्क्वायर बाई n स्मॉल r स्क्वायर. वेलोसिटी होगी V r स्क्वायर अपॉन n r स्क्वायर, n स्मॉल r स्क्वायर. दिस B इज करेक्ट ऑप्शन.